Duraisamy Saravanakumar, Director, Graduate School, Graduate Research and Graduate Studies and Research, UE, St. Augustine. Professor Donnie, Boodlal, Vice President, Research, Academic and Student Affairs, the University of Trinidad and Tobago. Senator Daniel Rashid from the Department of Computer and Information Technology at UWI. Our keynote speaker, Professor Stephen Alexander, Director of the Brown Center for Theoretical Physics and Innovation, Brown University, USA. Members of the executive leadership, deans, deputy deans, directors, heads of department, and members of faculty from the UWI and our partner institutions, distinguished guests, postgraduate and undergraduate students, conference presenters and participants, volunteers, ladies and gentlemen. A pleasant good morning. For those of you all who don't know me, I am Adesh Ramsubhag, Dean of the Faculty of Science and Technology, and it is a great pleasure to welcome you this morning to the Frontiers of Research in Caribbean Science and Technology Forecast Conference 2026. This is the third installment of Forecast and the first that is being held in Trinidad and Tobago. Forecast is held every 2 years, and it was initially started in 2022 through a collaboration of the science faculties of the various UE campuses and the University of Technology in Jamaica. It has since expanded with the University of Trinidad and Tobago and the University of Guyana joining in 2024. And this year, we are pleased to welcome the University of the Southern Caribbean. Forecast is emerging as an important regional platform for researchers, academics, and other stakeholders to network, exchange ideas, and explore how science, technology, and innovation can contribute to the sustainable development of the Caribbean. Participating in scientific conferences alongside publishing research in scholarly journals is an important part of the academic traditions. Forecast therefore provides a valuable forum for introducing our postgraduate students to this aspect of academic and professional life, allowing them to engage with other researchers, receive feedback on their work, and develop their science communication skills. This conference also aligns well with the Faculty of Science and Technology's research agenda, which places particularly emphasis on building interdisciplinary research, increasing collaboration within and beyond the university, expanding opportunities for our postgraduate students and early career scientists, attracting external research funding, and ensuring our research responds to the pressing needs of the Caribbean. We are particularly pleased to be partnering with colleagues from institutions across the region to host this event. Such collaboration reflects the spirit of Forecast, bringing institutions together to respond to the complex challenges of the Caribbean societies, from climate change and environmental sustainability to health, food security, digital transformation, and emerging technologies. Over the next 2 days, we will hear from researchers across a broad range of disciplines. I hope that the discussions will go beyond the presentations themselves and lead to new collaborations, new research questions, and new opportunities for our students and institutions. I therefore encourage you to engage fully, meet new colleagues, exchange ideas, and explore opportunities to work together. On behalf of the Faculty of Science and Technology and the University of the West Indies, I again extend a warm welcome to you all. Thank you for being part of Forecast 2026, and I wish you a productive and enjoyable conference. So we begin the formal program with greetings from the UE School of Graduate Studies and Research, and it is my pleasure to invite Professor Duraisamy Saravanakumar, Director of the School of Graduate Studies and Research, UE, to bring greetings. Professor Saravanakumar is Professor of Plant Pathology in the Department of Food Production and has a distinguished publication record, including more than 75 papers in referee journals and 10 book chapters. In his current role as Director of the School of Graduate Studies and Research, he actively engages internal and external stakeholders to advance and promote graduate studies and the research agenda of the UWI, Professor Saravanakumar.
Thank you, Prof. Ramsubhag. Pleasant morning, everyone. All protocols observed. It is my great pleasure and honor to bring greetings on behalf of the St. Augustine campus of the University of the West Indies and Graduate Studies and Research. It is always good to see distinguished presenters and participants in the conference like this. This shows how important this conference is and how our participants value this conference. I sometimes used to question myself, why do we have conferences in the era of digital world where resources are freely available with up-to-date information on scientific findings and innovations, even to the extent of short videos and graphical presentations, recognizing that people are not readily willing to read and digest in the recent days. Why do we have conferences while we can speak with anyone and meet virtually using our iPhones and Androids in real time, having the entire world in our hands? Yet, the conference like this is vital for human interactions, refresh our ideas, and share innovations. Building deeper networks and develop and implement research agendas, create impacts in resource-constrained small island developing states like ours, and more than that, make commitments and declarations the way forward for better society, better country, and the region. For example, the mathematics researcher and professor John McCarthy, who coined the term artificial intelligence in 1956 at the semi-conference styled workshop, would not have thought that artificial intelligence and machine learning going to revolutionize the world. At the UWA St. Augustine campus, even before we know the names of artificial intelligence, we have done a lot of work with respect to data science, machine learning, and intelligent systems. We have one of our distinguished scholars here, Professor Patrick Hussain, and similarly, the Artificial Innovation Center from the Faculty of Engineering. And of course, the work that is going on with the Faculty of Science and Technology, with the computer science in specialization in artificial intelligence. So in that regard, the campus has been doing extremely wonderful research with respect to all these growing and emerging areas. Similarly, the growing Caribbean talents and intellectuals, when joined together, the science of creativity and the magnitude of innovation can multiply enormous times. That's how I see this conference, which brings multiple institutions together. The UWI, the premier leading research institution of the region, University of Trinidad and Tobago, of course represented this morning by Prof. Boodlal, University Technology of Jamaica, University of Southern Caribbean, and University of Guyana. Along this line, the Office of Research at the UWI has awarded 23 graduate scholars to undertake research internship within the Caribbean countries through ICAMP scholarship. We call it as Intra-Caribbean Academic Mobility Program Scholarship, funded by the European Union. Under this program, UWI, UTT, and University of Guyana and private industries have actively collaborated to empower postgraduate students enrolled in the programs ranging from cybersecurity to data science, food security to food and agro-processing technology. This again shows the value of collaboration when institutions join together. I do ask myself another question. Is this conference only for researchers and only to disseminate the research findings? The answer I would know, definitely not. This is to discuss the research needs of the public and private sector organizations and bring solutions in all spheres of science and technology for the sustainable Caribbean. While I was compiling the research digest during our research festival last year, I realized the range of significant contributions made by the eminent researchers and graduate students of this Faculty of Science and Technology at the St. Augustine campus. Starting from UV-made product, Sealit, which is developed from the Department of Chemistry, discovery of adjuvants to counteract antibiotic resistance, antimicrobial lipopeptides from biological organisms for potential use in clinical experiments. And of course, we have Prof. Hari, and they have been collaborating with the Faculty of Medical Sciences as well. Developing the biometric identification technology named Identity, mathematical modeling studies for potential cardio interventions, valorization of seaweed for use in sustainable agriculture, then nanocellular technology for renewable energy production. I can list on and on. Of course, you're going to see the tribute to one of the finest researchers that we had at the St. Augustine campus this morning, Prof. John Igard. So this is the magnitude and the significance of the research that is happening on the campus. In this regard, I compliment and congratulate the Dean, Professor Adesh Ramsubhag, and his entire team of the Faculty of Science and Technology for hosting this conference and for leading impactful research on this campus. Before I close, I take this opportunity to mention two ongoing activities of the University of the West Indies. First one, to encourage the culture of research, the culture of innovation, the culture of manufacturing and commercialization, the St. Augustine campus has been hosting annual Principals Research Awards that are open to public in two categories. One is Principal Special Innovation Award with cash reward of $5,000. The other is Hurricane and Earthquake Alleviation Research. We call it as CLEAR Award with a cash reward of $10,000. It's open to public. Therefore, I encourage the young talents to consider sending your innovations and applications to us as we close these applications on 28th of September. Second one, this year, August 2026, it makes 30 years of excellence in the graduate education and studies since the establishment of School for Graduate Studies and Research in 1996. At this moment, I would like to recognize the presence of Professor Patricia Mohammed, who is the former Director, School for Graduate Studies and Research. Thank you for being here, Prof. So with respect to that 30 years anniversary, we have been rolling out a lot of activities, which includes the One UWI Postgraduate Student Conference and the Research and Innovation Display during the week of graduation on campus. Then Anniversary Gala, which is going to take place as a fundraising activity at Jamaica Pegasus on December 7th, 2026. So I would appreciate all your enthusiasm and active participation in those activities too. With that, I would like to express my special thanks to the Ministry of Public Administration and Artificial Intelligence. And of course, the minister is represented by the Honorable Senator here, Daniel Rashid. Thank you for being here. And also for the support of the Ministry of Public Administration and Artificial Intelligence in engaging the UWA researchers on various AI activities. With this, I wish and hope that you will have a productive conference. and deliberations and come up with the solutions and plans for the sustainable Caribbean. Thank you so much. May God bless everyone.
Thank you, Prof. Sarah, for those words and for continued support of the School for Graduate Studies and Research. And now we have greetings from one of our regional partner institutions, the University of Trinidad and Tobago. So it gives me great pleasure to invite Professor Donnie Boodlal, Vice President, Research, Academic and Student Affairs of UTT. And in his role as Vice President, Professor Boodlal provides strategic leadership for the university's research, academic and student affairs portfolios with responsibility for strengthening academic quality, research performance, innovation, partnerships, and institutional development. Professor Boodlal's academic and professional background is in process engineering and energy systems, with interests spanning engineering, energy sustainability, research, and innovation. His work focuses on connecting academic expertise and research with practical applications, industry needs, and the national development priorities. I now invite Professor Boodlal to the podium.
Thank you, Professor Ramsubhag. Good morning, everyone. Permit me to stand on protocols already established, but as I do so, I must acknowledge our keynote speaker, Professor Stefan Alexander from Brown University, and Senator Daniel Rashid. Thank you for being with us this morning. It is a pleasure and privilege to join you this morning at the opening of the Forecast program and to bring you greetings on behalf of the University of Trinidad and Tobago. I wish to first congratulate the organizers, the Faculty of Science and Technology, and everyone who has contributed to bringing this initiative together. You've heard it before, but it's worth repeating. Programs such as this are important because they create a space for researchers to do something that I think is sometimes difficult to achieve within the normal structures of academia. And that is to come together, exchange ideas, challenge assumptions, and explore possibilities across disciplinary and institutional boundaries. This is important because we are living in a period of extraordinary change. You probably would have heard people say transformational dimensions. You've heard of some of these transformational areas. Artificial intelligence is transforming how we work and how we generate and analyze knowledge. Climate change is placing increased pressure on our economies and societies. Energy security, food security, public health, environmental sustainability, and technological resilience are becoming increasingly interconnected challenges. Folks, I'm sure you will all agree when I say none of these challenges can be adequately addressed by one discipline, one institution, or even one country. They require collaboration. Prof. Sarah spoke a lot about collaboration. So I won't add a lot to that, a lot more, except to say that, when you want to reach fast, you walk alone. But when you want to reach far, you walk together. UTT and UWI, and we encourage the other partners, have been collaborating for quite a while. And we are seeing how far it has taken us, and we are seeing how far it can continue to take us. So with open arms, we welcome the other institutes in this true spirit of collaboration as we forge together. We do this because our responsibility is simply not to generate knowledge as universities. We have a responsibility to ensure that knowledge is relevant, that it is shared, that it informs policy and practice, and ultimately that it contributes to improving the lives of our people. For Trinidad and Tobago and the wider Caribbean, this responsibility is even greater. We cannot afford to see ourselves only as consumers of technologies, ideas, and solutions developed elsewhere. We must also become creators, innovators, and exporters of knowledge. We have the intellectual capacity to do this. As such, successful research projects should not only answer an academic question, we should also be asking, what problem does this help us solve? Who benefits from it? Can it be translated into a technology, a policy, a business opportunity, or a better way of doing things? And as I said that, I remember working with some of my colleagues at UWI, Professor Patrick Hussein, in particular, supervising and co-supervising students on projects precisely answering those questions. So, Prof. Sarah, very rich platform to build upon. Research excellence and societal impact should not be viewed as competing objectives. They should reinforce each other. I also believe that we need to be much more deliberate about developing the next generation of researchers. The students and young academics in this room and those that will be taking part in the conference over the next 2 days, you are not simply participants in today's program. You are the people who will shape the research agenda of the next decade and beyond. I encourage you, therefore, to use this opportunity fully. Do not simply present your research and leave. Find someone whose work is different from yours. Ask questions. Share an idea that may not yet be fully developed. Explore collaboration. Think about how your research can be applied in a context different from the one in which it was originally conceived. These are thoughts of innovation. Some of the most important breakthroughs in science and innovation have occurred because someone was willing to cross the boundaries of a discipline and ask a different question. Today's program and over the next 2 days, you have an opportunity to do so. I'm particularly pleased as well for the dedication and tribute to the late Professor John Agard, ORTT. That is particularly meaningful to me. Professor Agard has shaped in many ways my field and what I know of my field. So his legacy reminds us that the contribution of a researcher is measured not only by the work produced during a career, but also by the people inspired. This is perhaps one of the greatest responsibilities we have as academics and researchers, to leave the research environment stronger than we found it. We should therefore be ambitious, not only for ourselves and our institutes, but for Trinidad and Tobago and the Caribbean. Let us build research that is globally competitive, but locally relevant. Let us build partnerships that move beyond ceremonial agreements to actual projects, technologies, and outcomes. Let us create opportunities where our best young minds can see research simply not as an academic pursuit, but as a pathway to innovation, entrepreneurship, national development, and global contribution. And let us be prepared to ask difficult questions. Because progress does not only come from confirming what we already know, it often comes from challenging what we think we know. As we begin forecast, I leave you with one simple challenge. Do not ask only what your research can discover. Ask what your research can change. I congratulate once again the organizers, and I thank you for the opportunity to be part of this important initiative. UTT is proud to be part of this initiative, and I wish you all a stimulating, productive, and inspiring forecast. Thank you again, and good morning.
Thank you, Prof. Boodlal, and thanks to the UTT for its partnership in this event. So now we have a message from Professor Aldrie Henry Lee, Vice-Chancellor for Graduate Studies and Research at the University of the West Indies. Professor Henry Lee is a distinguished sociologist and scholar whose research has focused extensively on social policy issues in small island developing states, including poverty, gender, human rights, social production, and childhood. Professor Henry Lee is unable to join us face-to-face, but she has kindly provided a pre-recorded message for this morning's ceremony. I am now pleased to invite you to view her greetings to the Forecast Conference.
Marie Bell Antoine, Vice-Chancellor and Campus Principal, Center Custody, UWI, Professor Adesh Ramsubhag. Professor Marie Bell Antoine, Vice-Chancellor and Campus Principal, Center Custody Campus, UWI, Professor Adesh Ramsubhag, Dean of the Faculty of Science and Technology and Chair of this opening ceremony, Senator the Honorable Dominic Smith, Minister of Public Administration and Artificial Intelligence, representatives of our partner universities, other special invited guests, our keynote speaker, presenters, students, ladies and gentlemen, good day. It is indeed a pleasure and a privilege in my capacity to bring greetings to you at the opening of the Forecast 2026. Under the very timely theme, Science and Innovation for a Sustainable Caribbean. I commend the Faculty of Science and Technology at the University of the West Indies and all collaborating universities and partners for bringing us together for these two important days of scholarship, dialogue, innovation, and partnership. The title Forecast is itself particularly appropriate. To forecast is not simply to predict what is coming. For us, at universities, it must also mean anticipating change, preparing our societies for that change, and helping to shape the future we want, rather than simply responding to the future that arrives. And there could hardly be a more important moment for us to do so. The Caribbean faces a convergence of challenges. We confront the existential consequences of climate change, increasingly severe weather events, threats to biodiversity, pressures on water, food and energy security, public health vulnerabilities, technological disruption and artificial intelligence, changing labor markets, and persistent development constraints associated with our status as small island developing states. But we are also a region, ladies and gentlemen, of extraordinary intellectual capacity, creativity, and resilience. Our responsibility as researchers is therefore not merely to catalog our challenges, it is to produce the science, technologies, evidence, innovations, and policy solutions that allowed Caribbean societies to confront them successfully. That is why this conference matters. The scientific research that we conduct must ultimately answer some very practical questions. Whose lives will be improved by our research? What Caribbean problems are we helping to solve? What policies must change because of the evidence we produce? What innovation can move from the labs into communities, businesses, and industries? And perhaps most importantly, what kind of Caribbean are we helping to create for the generations who will come after us? Science becomes most powerful when knowledge is translated into action. It is especially fitting that today's program includes a dedication and tribute to the late Professor John Agard, ORTT. Professor Agard embodied so much of what forecast represents. He understood that environmental science must inform development planning, public policy, and decision making. We salute him for his contribution to the UWI, Trinidad and Tobago, to the Caribbean, and to the international scientific community. That is an enormous legacy. May his distinguished contribution continue to inspire our researchers and students. Ladies and gentlemen, this conference is also particularly meaningful because 2026 marks the 30th anniversary of the UWI School for Graduate Studies and Research. For 3 decades, the SGSR has worked to strengthen research capacity, support our researchers and postgraduate students, promote research excellence, and help create the knowledge required for Caribbean development. An anniversary, however, must be more than a celebration of longevity. We must ask ourselves, what difference can the school continue to make for the next 30 years? This forecast conference provides part of the answer. Every research paper presented today, every new finding discussed, every postgraduate researcher given a platform, every interdisciplinary conversation initiated, and every collaboration emerging from this conference represents the very essence of what graduate studies and research are intended to achieve. This conference therefore forms part of SGSR's continuing story of excellence. Ladies and gentlemen, I'm also particularly pleased that Forecast brings together colleagues from universities across our regions. The problems facing Caribbean societies do not respect disciplinary boundaries, institutional boundaries, or national boundaries. Neither should our research. No single university, faculty, department, or researcher can adequately address climate resilience, food security, sustainable energy, artificial intelligence, biodiversity loss, or public health threats working in isolation. Our comparative advantage as a Caribbean region lies in our ability to collaborate. Researchers, students, as you participate in Forecast over the next 2 days, I therefore encourage you to do more than listen to presentations. Find a collaborator, meet a postgraduate researcher whose work interests you. Be a mentor to a student or a junior researcher. Identify an idea that could become a joint research proposal with researchers from another university. Think of the next step to publish these very important research findings. Make sure that these findings become known to our policymakers. Consider whether an innovation can be commercialized, scaled, or introduced into a Caribbean community. And ask yourselves, what can we accomplish together that none of our institutions can accomplish alone? Let Forecast be a place where ideas become partnerships, partnerships become projects, projects produce evidence, and evidence produce meaningful change. That would be a very fitting contribution to the 30th anniversary of the School for Graduate Studies and Research. Ladies and gentlemen, the future of sustainable Caribbean development will depend significantly on our capacity to generate and apply knowledge. Our small size does not limit the size of our ideas. Our vulnerabilities do not diminish our capacity for innovation. Our geographic separation need not prevent us from building a truly integrated Caribbean research community. I congratulate the organizers, our partner institutions, our presenters, and all those who have contributed to making Forecast 2026 possible. I wish you 2 days of stimulating presentations, productive dialogue, new partnerships, and most importantly, new possibilities for the Caribbean science and innovation. May Forecast help us not only to anticipate the future, but to create it. I thank you. All the very best.
And we would like to thank Professor Henry Lee for those encouraging words. A little bit premature, but it's okay. So, right. So, unfortunately, campus principal is unable to be with us due to circumstances beyond our control. And Senator, the Honorable Dominic Smith, has been called to an urgent meeting. But we have Senator Daniel Rashid, who is from our faculty, Science and Technology, from the Department of Computer and Information Technology, and he is representing the minister to bring some short greetings. Senator Rashid.
Thank you. Chairman of the proceedings, Professor Adesh Ramsubhag, Dean of the Faculty of Science and Technology, Professor Aldrie, Pro Vice-Chancellor, Graduate Studies and Research at the University of the West Indies, Professor Donnie Boodlal, Vice President of Research, Academic and Student Affairs, University of Trinidad and Tobago, Professor Prof. Sarah, Director, School of Graduate Studies and Research. And it's actually my first time meeting Prof. Sarah, but I've heard so much about him from my department. Distinguished keynote speaker, Professor Stefan Solomon Alexander from our friends at Brown University, deans, members of faculty, and staff of our partner universities, representatives of government agencies and industry, researchers, graduate studies, graduate students, especially invited guests, members of the media, ladies and gentlemen, good morning. I bring greetings on behalf of Senator the Honorable Dominic Smith, Minister of Public Administration and Artificial Intelligence, and of course, the government of the Republic of Trinidad and Tobago. It is an honor to address the opening ceremony of Forecast 2026, and I commend the University of the West Indies and the Faculty of Science and Technologies, the University of Technology Jamaica, University of Trinidad and Tobago, the University of Southern Caribbean, University of Guyana, and all of our partner institutes for convening this important regional gathering. This year's theme, Science and Innovation for a Sustainable Caribbean, could not be more timely, but more importantly, could not be more urgent. History teaches us a simple truth, and that truth is that no nation has achieved lasting prosperity without investing in science and technology. For Trinidad and Tobago, research and innovation are the keys to diversifying our economies beyond hydrocarbons. The government's decision to establish a ministry with responsibility for artificial intelligence reflects our conviction that AI is not a distant frontier. It is a present-day tool for transforming public services, agriculture, healthcare, energy, and disaster resilience. We are committed to building a smarter, data-driven public administration, one where digital services, streamlined systems, and AI-assisted decision-making put citizens first. But technology must serve our people and must serve them responsibly. As we embrace AI, we will do so with strong governance, data protection, and ethical frameworks that reflect Caribbean values. The challenges we face, climate change, food security, and the energy transition, demand Caribbean solutions to Caribbean problems. Our region must be a producer of innovation, not merely a consumer of imported technology. This is why gatherings like Forecast 2026 matter. They bridge the laboratory and the economy together, and the government stands ready to partner and research with researchers to translate your findings into policies and enterprises. To the students and young researchers here today, You are in this region's greatest resource, and you are this region's greatest resource. We must and we will create pathways for you to innovate. Permit me to also honor the memory of late Professor John Agard, out of the Republic of Trinidad and Tobago, whose pioneering work on sustainability and climate resilience shows the world what Caribbean science can achieve. So I urge you, when you leave this conference, leave not only with new knowledge, but with new collaborations and bold ambitions. Together, let us build a Caribbean that is sustainable, innovative, and sovereign in its own future. On behalf of the government of the Republic of Trinidad and Tobago, I wish Forecast 2026 every success. Thank you.
Thank you, Senator Rashid. So, ladies and gentlemen, we now come to a particularly special part of today's ceremony. The theme of Forecast 2026 is Science and Innovation for a Sustainable Caribbean. And it is therefore fitting that we pause to recognize the life and contribution of a recently departed member of the UE community, whose distinguished career embodied the very essence of what this conference seeks to promote. The late Emeritus Professor John Agard, ORTT, who was from the Department of Life Sciences, made an extraordinary contribution to science, environmental research, sustainable development, and to the intellectual life of the University of the West Indies and the wider Caribbean. His work reached far beyond our region, but throughout his career, he remained deeply committed to applying scientific knowledge to addressing the challenges facing the Caribbean and to ensure that this region had a strong voice in global discussions on sustainability and climate change. Forecast 2026, therefore, provides a fitting occasion for us to recognize his scholarship, leadership, mentorship, and service. The Department of Life Sciences has produced a short video tribute, which we will now view. There's also a special display at the Undercroft highlighting aspects of his life and work, and I encourage you to visit that booth. And we also have some displays here at the front of the stage. I didn't mention, but we are especially honored to have with us this morning Mrs. Marguerite Agard, Professor Agard's wife, and their son Andrew. We warmly acknowledge their presence and thank them for joining us on this occasion. So, ladies and gentlemen, we now reach the keynote address, which will be delivered by Professor Stefan Alexander, Director of the Brown Center for Theoretical Physics and Innovation at Brown University. And it's my pleasure to introduce Professor Jaira Jayaraman, who will do the formal introduction. And we all know Professor Jaya, Deputy Dean for Graduate Studies, Research and Innovation. And he has been the live wire, the driving force behind organizations for POCAS 2026. So I now introduce Professor Jaira Jayaraman to do the honor.
Pleasant good morning, ladies and gentlemen. I respectfully observe all protocols established. And it's my distinct pleasure to introduce our keynote speaker, Professor Stephen Alexander. I had a hard time to prepare a brief bio of a paragraph, after looking at his CV and all the things I see in the website. So apologies if I miss something. I try. Professor Alexander is a professor of physics at Brown University and an internationally recognized theoretical physicist and cosmologist. His research lies at the intersection of cosmology, particle physics, and quantum gravity, addressing some of the most fundamental questions about the origins and nature of our universe. Professor Alexander also has a strong Caribbean roots. He is a proud son of the soil. Born in Trinidad, he moved to Bronx as a child and went on to earn his undergrad from Haverford College, and his PhD in physics from Brown University. His academic career has included appointments from different universities, including Stanford Linear Accelerator Center, Imperial College of London, Penn State, Haverford College, Dartmouth College, so many, before returning to Brown as a professor. His achievements extend well beyond his research. He is a fellow of American Physical Society, a past president of National Society of Black Physicists, and the author of the acclaimed books, just one I can say as an example, The Jazz of Physics and Fear of a Black Universe. And Professor Alexander brings another dimension to his work. He is also an accomplished jazz saxophonist who has explored the fascinating connections between music, creativity, and theoretical physics. Given our conference theme, Science and Innovation for a Sustainable Caribbean, we are especially pleased to welcome a distinguished scientist with Caribbean roots, whose career demonstrates the power of curiosity, creativity, and interdisciplinary thinking. Ladies and gentlemen, please join me in welcoming our Forecast 2026 keynote speaker, Professor Stephen Alexander. Thank you, sir. Oh, I see. Yeah. So I want to make it as a surprise. You broke it.
No. Well, there won't be music, but this is a physics demonstration.
Oh, okay. Physics.
So I need to plug this in.
There we go. Yeah. Oh.
I'm happy to email the talk. I think I have enough power. But how do I hook it up? Yeah.
Can you pull it out?
Yeah. I'm not familiar. Yeah.
Are you on this presentation?
Yeah. Yeah, my talk is I can
Wait, I know what to do. Yeah, you can.
I can email
You
it to you.
join the Zoom and share screen.
I can
Yeah.
do that, yes.
Yes.
But I need to get online.
I get to be right.
Okay, how's that? Take no time.
Hook up.
On my phone.
No.
No, what's up?
Yes.
Okay, yeah, even better. What I'll do is I'll update the PDF, so it's fast. All right, very good. Very good. So we call innovation.
Hello.
Okay.
Nice.
And it says that you. You have five. What's the sense code?
Yeah, I think it's not. Yeah, right. That's yeah, it's not.
Okay, is that it?
Yeah, yes, I think it's
I see F. Okay. Check it out. Time is draws, right? So.
Okay, so in business.
Beautiful.
nice.
How do I advance this? How do I get to the next slide?
I think you could probably scroll.
Is it like, okay, that's good. For some reason, it's shared, like, how do I get on the full screen? Different agreements. Well, there's a full screen mode. Oh, sorry.
PDF. Using our. Yeah.
I'm just worried about how to make the screen.
The controls.
Okay, that's much better. All right. Thank you, Phil. All right. My colleague, Professor Sherwin Hack, what's going on here? Okay, I guess that's not going to pop up again, right? And it seemed to have returned back to its bad ways. So,
Okay. Should we do the other one? With Chrome? Yeah, that's right. I think, yeah, this is Chrome.
what do you do last night?
Yeah, the other is giving this news, so I think
Okay.
really best we can do.
Okay, no problem. Okay, I guess we'll have to do this way. All right. First of all, I want to dedicate this talk to my late grandfather, Muhammad Ali, who grew up in Princess Sound, went to presentation of college. And I guess the 50s went to Cambridge University, studied there. So yeah, I am full circle. And the visionary Paul here. So I want to dedicate this talk very much to his memory. I never met my grandfather. He passed on quite young while he was living in England. He was a boxer. I guess he was a bad boy too. He was Trinidad's top distance swimmer. Okay, so he was a national champ. So he was quite a colorful individual. And I guess I didn't fall too far from the tree, as the saying goes. So I've heard that I'm also quite a character myself. And as my dear colleague, Dr. Hack, Professor Hack said that I left Trinidad, but Trinidad never left me. And this is a picture I found. This is back in 1979 at Peoria Airport, back in the days where there was a big goldfish. I still remember the image of this gigantic fish in that pond in the back there. That's my grandfather on my mother's side. That's me with the brown suit and my cousins. And this is, yes, you can see, we all were not happy. We were all, look at the grimace in our face. We're all very sad. I was sad to leave the island. So I had to make the most out of it, and I think I did. returning, going to the United States, growing up in New York City. And, you know, I kind of want to sort of, my talk is broken up into 3 parts. The first part will be kind of talking a little bit about, again, this conference and the theme of this conference is actually perfect and is about my concept of what we call not old talk, but crosstalk. Okay, the ability to talk across fields, and the fact that that has been my secret weapon for my success. Yes, in the States and the institutions that I occupied had been very competitive environments, needless to say, and I think that I want to kind of speak to my Caribbean roots, my Trinidadian roots, and how those things natural to that was sort of natural to our heritage, our culture. You know, we come from the land of Carnival, Calypso, the steel pan has global impact. And this is a land where many cultural traditions have collided to create this new phenomenon that is now taking over the globe. Last year, I was at Central Park. There's a big Central Park in New York City. Thousands of people were lined up, sold out for days in a row to see Cats play. And many of those people were not Trinidadians or Caribbean people. They were New Yorkers. So the impact of our culture, our innovation, places us in a very natural, hidden advantage to actually, you know, as we talk about this age of AI, I see this actually as an opportunity for us. And I want to actually reframe this as an opportunity in terms of this transformation that is happening in front of our eyes. So it was because of this sort of natural upbringing that I have, coming from a multicultural background, Trinidadian background, having family from different religions, kind of made me appreciate that crosstalk, maybe appreciate talking to others who are not in my field. And that appreciation has taken me far, and I want to talk a little bit about that. And then the second part of my talk, of course, I'm going to talk about my field so I can get the young people excited about this opportunity. And then I want to talk about the future and the present. So, so that's a little bit of my story here, and I'm going to move on. As you see there to the upper right-hand corner is a picture of me and my PhD advisor, Professor Leon Cooper, who won the Nobel Prize in Physics in 1972 for the discovery and the theoretical quantum explanation of the theory of superconductivity, which has led now to a lot of our semiconductor technology involving cell towers and levitating trains and now the quantum computer. Leon taught me, even though it was very natural to my background, my Trinbagonian background, the importance of cross-disciplinary interface. So for example, in 1973, Leon left solid-state physics, quantum physics, and moved into the field of neuroscience to form the Institute for Brain and Neural Systems at Brown University. And he took ideas of statistical mechanics having to do with how the quantum spins and the emergent phenomenon of magnetic fields. And he and a number of other people, including John Hopfield and Jeff Hinton, who later on won a Nobel Prize, Leon would have won 2 Nobel Prizes, to take that idea and map it into how neurons interacted. And now, fast forward 40 years, now we have AI and artificial and neural network. So that was one of Leon Cooper's example of taking an idea from one field and bringing it into another field. And that freedom of mind to be able to do that was a move that he made that basically transformed. Another place was his discovery of superconductivity, would have to do with the pairing mechanisms of electrons can pair and therefore transcend the repulsion that they naturally would have to attract and form a quantum superconducting state. And that is now the architecture of the quantum computer. So these levels of innovation is nothing new. And I really want to now exemplify what that might look like for us here in the Caribbean and beyond. So I mean, I was recently on Tobago last night, actually. The flight was, happily delayed. But, so Tobago is actually a small island. I mean, we're not really a small island. But, what this island teaches us is, about approaching big, mixed up questions. Okay, so questions that even sometimes the question is not even well defined. I'm going to talk about now my field, or quantum cosmology. So if you want to learn more about this field, of course, you can buy my book, The Jazz of Physics, which was published in 2015 and it's still selling well. I guess I was able to buy my house with that book. So I guess, little thing, I didn't even know how to form a complete sentence when I was beginning university. But, you got to work on your weaknesses, right, Sharon? Okay, so help me back. So now I want to begin. Now, one of the things I often do is I teach intro physics, one of the classes I teach. And instead of, we have these boring demonstrations of a pendulum and all that kind of put people to sleep. I instead, for my entire class, will use my instrument as a device to demonstrate the physics. So we will now begin. I'm now going to begin with the very birth of what we call Western science. It began with Pythagoras, at roughly 580 BC. And Pythagoras had spent over a decade in Egypt, in the mystery schools in Egypt. And when he came back to the island of Samos, the Greek island of Samos, his father was a goldsmith. He had a lot of money, so he was able to go on a long vacation. He actually went to learn things. And he came back with this idea that he could hear the sound of the universe. He created a word. It's a Greek word, and that word is called cosmos. That is a Greek word that was created by Pythagoras, and it means that which gives order in the universe, in the world. And the idea of cosmos was to understand the motion of the planets at that time. At that point, the West did not know anything about motion, about what caused motion. And that project of understanding motion took about 2,500 years for smart people to figure out. I'm gonna zoom past that very, very quickly. But his basic idea was the idea called music or harmony of the spheres, which also involved the notion of using the whole integers 1 through 4. He believed that by combining the ratios of these whole integers, that the planets organize themselves in this integer ratio to play a harmony. To prove this to himself and to his doubting colleagues, he decided to make an instrument that we're kind of looking at a version of it here, called the monochord. It's just a one-string guitar. But I'm going to demonstrate this monochord on my saxophone. So instead of a string holding vibrations, this instrument is going to hold vibration of airwaves. And what we're looking at here is at the top is the longest vibration. We sometimes call that the fundamental. That is the longest vibration that is held and fixed in this instrument. Obviously, if I lengthen this thing out, that's kind of what we're looking at here. And what we're going to do is we're going to do this experiment and understand his idea of harmony of the spheres. So the first thing I'm going to do is play the fundamental, which is the lowest tone. And then I'm going to play 1/2 of the ratio of that vibration. So I'm going to clip that vibration in half. I'm going to clip it in a quarter. I'm going to clip it in a third. And we'll see what we hear. That's the lowest. I'm now going to play in half. And you guess what we're going to get? Okay. We get now what we call the octave. I'm now going to play 1/3. So 1, 1/2, 1/3. The perfect fifth. I'm now going to play 1/4. That is the perfect fourth. So yes, while trying to understand the motion of the planets, Pythagoras also discovered the Western musical scale, which is pretty much all of our music is based on. right? So music and science, because Pythagoras is the one that also created the idea of inductive mathematical reasoning, doing mathematical proofs, the tradition of modern mathematics. At the same time, music and this way of doing science was born at the same time. Why am I bringing this to your knowledge? Because I wasn't taught that when I was a student. So as I was growing up, I grew up with this way of trying to be a musician or trying not to be a musician because my parents were like, you better not go to school and study music. You need to pay your bills and take care of me when I get old. Yes, so I instead studied physics, but was doing music on the side. Later on, I realized that these two worlds were very much connected, and I was able to use this musical reasoning to give me the advantage in solving physics problems that my other colleagues were not able to solve. And that is why was I able to invite that, was I want to attribute that to my Caribbean roots. Otherwise, I would have been like, heck no, I should be in this box or this box and I should identify as a musician. No, that's not how we do it here in Trinidad and Tobago and in the Caribbean. So that's a little thing about that stuff. But you would say, okay, obviously now I'm moving into talking about my field a little bit. I'm going to give you a little sense of what I do for a living, how I pay my bills. So fast forward from 580 BC to 2,000 years later, all these philosophers are trying to understand how planets were moving, and they were all getting it wrong. Aristotle, Plato, right? Copernicus, all these people who were students of Pythagoras tried to use this kind of geometric, perfect symmetry, perfect circles, so-called epicycles, and failed miserably to understand the motion of the planets. Johannes Kepler in the 1600s returned back to this because now he actually had data. Remember, science is nothing without data. Theory is nothing without experiment, and experiment needs theory. So he had data from his boss, Tycho Brahe, who was a Dutch, royalty. He had a metallic nose because it was cut off in the duel. He was a character. But after Tycho Brahe passed away, he used his data and returned back to Pythagoras' way of thinking. Now, what he was looking for in the motion of the planets was the perfect fifth. The perfect fifth is very important in music. As you can kind of see here, if I kind of play down a perfect fifth, that's a movement in a perfect fifth. It likes to move to what we call the home key. The perfect fifth is important. That's a ratio 1/3 or 2/3, depending on how you look at it. He was looking for that. So he wrote down musical notes associated with the velocity of the planets. He took the ratio of a planet as it was furthest from the sun and the velocity of the planet when it was closest to the sun, took that ratio and wrote down a musical notes. And you can see here, Terra, all the way to the right, or to your right, yes, is the notes for Earth. And it sounds horrible, actually, right? So it didn't work. But he found the perfect fifth in a different way. By combining the data, he found this ratio 2/3 in a universal equation, which was the first equation written down by any human being associated with an astrophysical phenomenon. This equation is called Kepler's law, and it crowned Kepler as being the first astrophysicist, the first person to write down equations for celestial body. That didn't work for one planet, but for every single planet that we have observed, on the order of 1 billion planets now that the Kepler space satellite have seen, obeys this equation. What is the equation? The equation says that when a planet moves around the sun being the foci of an ellipse, how long it takes a planet, which is t, the period, a year, if you square that, it predicts how close the planet is, which is a, to the foci, to the sun. And this equation has the ratio 2/3. So he found a harmony in the equations. And this is what led now Guess who was paying attention to this, people? Right up the street in England, Isaac Newton. Isaac Newton tried to explain this equation, and it allowed Isaac Newton, enabled him to invent calculus and Newton's laws. And now the tradition goes, because from there is Albert Einstein, and from there is Schrödinger. So it all started with this idea of music and the cosmos. So this continues, the Kepler satellite is continuing to find planets, and they all obey this universal equation for planetary motion. I want to now move into talking about what does quantum mechanics, quantum physics have to do with the cosmos. It begins with a story of patterns. We like patterns, right? If you look at this, right? If you look at the pattern of how the notes are placed in a steel drum, right? It's a reason why Elie Manet did that, right? The inventor of the modern tuning of the pan, because the placement of the resonances of those notes geometrically, right, is optimized with the perfect fourth because of what I just told you with these notes. You see, so Caribbean innovation has always been there. And what we're looking at here is a pattern. If you look to the center there of that, up to the on the octet, where it says octet, you'll see the neutron and the proton. This is much of the subatomic matter that we're made up of. This is how the periodic table organizes itself based on the stability, right, and rigidity of the nuclei, neutron and proton. However, the neutron and the proton are not what we call stable states of other excited realizations of themselves. And these other particles organize themselves. If you plot their masses versus the charge that you find when you collide these things together, it creates other excitations, so to speak, just like, right? And that provides a pattern. And Murray Gell-Mann saw this pattern, these patterns that the data represented, and found that it had to do with a beautiful piece of mathematics called group theory. And he was able to write down the theory of the strong interaction based on symmetry. So the use of symmetry is very powerful in quantum physics and understand the subatomic world. All right, so we can now organize all the laws we call the standard model, which has been experimentally confirmed to the order of 15 decimal points between the prediction of theory and experiment. This is a quantum field theory that is based on these symmetric vibrations that we see in the realizations of subatomic particles. So you have your in-house astronomer here, so I'm going to make her smile. So you see at the corner here, I'm very inclusive, Professor Hack. My field, quantum cosmology, involves taking data and studying the organization of data from the largest distances in the sky, the subatomic world, because all of matter is based on the laws of quantum physics. Einstein's theory of general relativity, we call it gravity, I'll talk about it in a second, and of course, particle physics. So all of these worlds have to talk to themselves in order for us to understand what. And the question that we're going to talk about today, in my little lecture, is how does structure form in the universe? What do I mean by that? Well, you see, when you look at the night, when you look outside, you'll see a star, a sun, and our galaxy, which is a disk of other suns, occupies in the order of, billions of such stars. It is a rotating body of stars, right? And we want to understand actually how did that galaxy itself form. I'm going to show you data of a universe where there were no galaxies present in the past. So we want to understand how did all the structure that we see out there, is it all willy-nilly? Is it all like just, random? Or can we use physics to understand that? But then what's interesting is that when we pursue these basic questions in basic research, it inevitably, because of crosstalk, leads to new innovation in ways that we cannot predict. The same way Leon Cooper, by trying to understand the quantum mechanics of electrons, it led to, right now, the qubit of the quantum computer, or the neural network of AI. We have no idea what this crosstalk and what exploring these questions with the correct opportunities, Mr. Senator, would lead to. So I want to now, of course, discuss quantum mechanics, and I'm just discuss quantum mechanics with my instrument. So what is quantum mechanics? Well, we are told that, first of all, we're not quantum mechanical. We're made up of gazillions of electrons and protons and stuff. And when they organize themselves, you know, biochemistry, Dean, becomes into play. It reigns supreme. But, you know, underlying those chemical bonds are resonances, quantum resonances that enhance the bonding mechanisms. But what is quantum mechanics? Well, you learn about electron clouds. That is nonsense. Ain't no electron cloud. The electron, according to Richard Feynman, the quantum particle is very different. I was going to throw something, maybe this bottle of water. This is a classical object. This object is not obeying the laws of quantum mechanics. If I drop this thing, should I drop it? I'm not going to be a bad boy. I don't want to get this. Remember the last time, I left my when I was 8. I still have memories of that time. That is brutal. That is teacher. I've been on my 3 times a day. I used to remember, and Mr. Navi was to me. Mr. Navi, where you? There was a police on the side. He said, I pick my own whip. So stripping me, I went and I got the thinnest whip. I didn't know that that's the one that happened. But anyway, I'm going to drop this thing. I drop it. You know, clearly it traversed one unique path. You're like, so what? The quantum world is very different. The quantum world, the quantum particle, like the electron, what it does to get from point A to point B, it actually considers all possible paths. So almost if the electron splits up into an infinite possibilities to get from point A to B. You say, well, that's stupid. Why are you saying such a thing? It turns out that if it didn't do that, it wouldn't get from point A to point B. It is in that consideration. And the way you should look at this is like, you see, if you look at a bunch of waves colliding together to make one gigantic wave, in a lot of ways it's because of the wave-like nature of the electron. The waves of these electron possibilities collide and perform a coherent superposition, or what we call, it adds up to form a big electron waves, and that's what you and I see as the electron going from point A to point B. It's a very weird thing, but we now use this wave-like nature to make our semiconductors work. That's what we're using. These PN junctions is using the wave-like nature to work. So our technology is based on this weird thing. Now, I'm going to demonstrate this in terms of music. So a classical particle will go from all right. Quantum particle will do something like or it can go so it can consider all possible paths. So in a sense, it's not the electron, quantum particles are actually improvised. That's the way to think about it. And it's because of that improvisation that we get all the magic and all the life in nature. Okay. I want to talk about now another concept called symmetry. We talked about symmetry. Symmetry is a very simple concept. Here is my computer thing, right? If I rotate this thing by 180 degrees, that's called a transformation. And it retains its original shape. So a transformation and being able to see the same object this has what we call a twofold symmetry rather than a square would have a fourfold symmetry. I rotate 4 times, right, to get back the same object. In this case, I rotate twice and I get back the same object. So it turns out that physical laws themselves, what do I mean by physical law? Our physical laws are described by equations. Equations are us. These equations have a built-in symmetry. So if I transform the variables of that equation, it looks the same. And this gives us very powerful economy in manipulating and predicting and using those equations for technology. and also building new equations. And part of what I do for a living is I build new equations and build new theory. I'm not the only one that does that, obviously. Jazz musicians do it as well. So you see a picture here of John Coltrane, one of the greatest, probably the greatest sax jazz player in history. Check out a song called, his album called A Love Supreme. And you see here, he's written down notes associated and trying to identify patterns, geometric patterns, and exploiting the symmetry between the relationships and the transformation of notes. However, life is boring if symmetries, where's the water I just dropped? Oh. Symmetry is, and by the way, when I talk about symmetry, this doesn't only apply in the subatomic unseen world, it actually applies in the macroscopic world. I have a colleague that's a sociologist, and he looks at symmetry in the organization of population, for example. So this tool is very powerful. Symmetry is not interesting though. Symmetry must also be broken. So what we're looking at here, this picture to the left, you see a picture of an electron. So what you should look at here is that all the way to the right, you see U and D. That U and D is what we call a quark. Quarks come together to make the proton and the neutron. So inside of a proton, for example, or a neutron, you have three quarks, what we call an up quark, a down quark, and a strange quark. There's names for these things, right? But the important thing is that an up quark can transmute into a down quark. And when it does that, the neutron becomes a proton. But when the up quark transforms into a down quark, it emits a particle. That particle is called W. It's very similar to the emission of light, like you're seeing here, from an electrical current. That light is a photon. That is a carrier of the electromagnetic force. This W is similar to a photon. It carries the weak interaction, the weak nuclear interaction. So when the up quark turns into the down quark, it releases a W boson. But here's a catch. The W boson is spinning in a handed way, spinning around in a left-handed manner. If I look at the mirror reflection of that interaction, I should see a right-handed object and right-handed quarks and stuff like that. When the experiment was done, this is what we call a mirror symmetry, or fancy word for that is called parity symmetry. I look at an interaction in a mirror, sometimes we call it chirality in chemistry. If I look at the mirror interaction, it turns out that 100% it does not happen. And this led to 2 Nobel Prizes and the establishment that out of all the 4 interactions known to us in nature, the weak interaction violates parity, violates mirror symmetry maximally. Now you can say, who cares about that? Well, the thermonuclear fusion that happens in the sun would speed up billions of times, and the sun would not live long enough to sustain life on Earth. And without this violation of symmetry, there would be no life. So we need this weak interaction and this violation of the symmetry. And this remained a big, big mystery. And so one of the things I like to toot my horn about, I shouldn't be bragging, was that one of the things that I was able to do as a postdoc at Stanford was to figure out how to use this to establish the question is, why is there more matter over antimatter in the universe? We could measure that effect with 10 decimal points accuracy, and I was able to construct a theory using a variant of this in the context of general relativity. I'll talk about that in a second to understand that, and that's probably the reason why I'm standing here. I got tenure at Brown or something like that. Well, my colleagues voted me to be a director or something. Okay. But now I'm going to bring this down to earth. I'm going to tell you now the story. I've given you enough tools, believe it or not, secretly, by talking about waves and sound and vibration to now explain to you how structure form in the universe. All ready for that? All right. As long as I get my duck lid on. All right. All right, good. Oh, but people could say this guy give me real, whatever the word talking. I don't want to use bad words up here. It's I'm in front of esteemed gentlemen and gentlewomen. I will not do it. Do not tempt me. I will save that for later. Nice talk. Namaste and all these nice words. I use nice words. Okay. All right. So curve. My friends, you're living in an illusion. That's the first thing. When you walk down the street and you see people, you should not, people are warped. And what do I mean by this? Gravity is not a manifestation of a force. No, that's not how you should think about it. What Einstein predicted is that this stage, this emptiness, is not empty. It is an invisible fabric where, if you think about a magnetic field, you want to, okay, take a magnet, put it next to the next magnet, and the magnet will attract. But those magnets are not touching each other. There's an invisible magnetic field that is exuding a force to pull the other magnet. So you can see even in empty space, you can have jumbie going on. We call that field. I'm going to come up with my new theory. I figured out how to have a field of the jumbie. You ready? And I got to set it up. You know, take me down to the bush and I put on the thing. And we're going to give a science talk called jumbie physics, jumbie quantum. I'm making a lot of money. Okay, I already have my innovation. All right. But the sun, if you see right there, warp space, and the contour of that warp space, the earth moves along that contour, and we call it gravitational force. The earth warps space, and the moon is going around the contours. Now you can say, that's dumb because I could just talk about a force to talk about the same thing. Why are you introducing all this complexity? Is because other predictions are made such that space can get so warped that it'll form a black hole. There's one sitting at the center of our galaxy, and every single healthy galaxy that we see in our universe, billions of black holes. We also have ripples of the space-time. That is not a force, that's called gravitational wave. The Nobel Prize was given for that. We have observed that. So there are other features of warping of space-time that has nothing to do with a force that also that includes the gravitational force. So that is the correct way to think about the physics of space and time, is that space could warp. All right. So that's one important ingredient to understand cosmology, is that the space-time around us is not a static feature, it's very dynamic, especially when you look on the largest distances. The other one is that if you believe that in 1922 and 1927, solutions of Einstein's theory of general relativity, that's the equation down. Very most beautiful equation I know. It is a tensorial equation made up of, that packages 10 nonlinear ordinary differential equations, sorry, partial differential equations, and notice that it has a beautiful structure. And it is insoluble. You have to use supercomputers and now AI to solve these equations. Okay, so we have a lot of work for engineers and computer scientists, by the way. We put a lot of y'all to work, and a lot of beers and all kinds of nice things, and juice and coconut water. The other thing, if you believe that the space is warped, the universe wants to expand, space expand. If you run the clock backwards, you can contract space where all the matter, all the energy is contracted to one point of infinite density and energy and curvature. Okay? If you believe that, then in 1927, Edwin Hubble looked at our telescopes, and you see on this line here, he sees that every point on that line is a velocity of a galaxy and how far it is. And it basically tells you the further the galaxy is from us, the faster it's moving, and that proved that the universe is expanding. How much time do I have? Okay. All right. All right, so that's one prediction. That's the data. Another prediction of this expanding universe, because I want to talk about what people say, I don't believe in this Big Bang crap. I'm showing you the data now. The other one is a black body spectrum. This is another observation when we look at photons in the sky. I'll talk about that in a second. That you see the dots, it lands on a perfect thermal equilibrium. That's another prediction of the equations of this theory. And the third is that when we look at millions, and now on the order soon to see billions of galaxies, we see a power spectrum. This is called the matter power spectrum And I don't know why how I can move my thing away from this beautiful graph. Is it moving? Okay, get out of here. All right. So this is looking at millions of galaxies and plotting basically its power or its brightness as a function of distance or redshift. And the black curve is a theoretical prediction of our standard cosmology using Einstein's theory of relativity and the description of matter as we understand it quantum mechanically. And that is the data. And it's so precise that if you tweak the theory, you will actually you're talking about percent deviations that can rule out theories. So I provide you 3 pieces of evidence as to why the universe is in fact expanding. And now we're in a position now, and I promise you in 10 minutes I'll be done, is to understand the problem of structure in the universe, to actually tell you that we don't have all the solutions. All right. So what we're looking at here is a picture of the large-scale structure in the universe. Every dot, if I zoom in, if you zoom in right there, you're seeing galaxies. If you zoom out, you're seeing on the order of billions of galaxies. And notice that when you look at that pattern, which is extended on the order of billions of light years, remember light years on the order of trillions of miles, okay? So it's an extraordinarily vast distance that we're looking at. We see a patterning. We see patterns. And whenever scientists see patterns, we get interested. We want to understand the physics of that pattern. This is now a 3-dimensional rendition of this large-scale structure. Supercomputers are used. I have an affiliation with the Center for Computational Astrophysics at the Simons Foundation, and this is a rendering of supercomputer simulations of what we call the cosmic web, which interestingly has the same network morphology of the human brain. Kind of weird. And this is like nice little pretty galaxies. But life would be uninteresting if that's all the data we had. This is picture. So it takes light, right? Light travels 186,000 miles per second. We're looking at light that took about 13 billion years to get to us. So we're looking at light of a source that's 14 billion years in the past. And that's what we see. So my friend and colleague, David Spurwell, the president of the Science Foundation, he was the co-PI of this satellite, multi-billion-dollar satellite called the WMAP satellite, which took a picture of the baby picture of the universe. And so what does this picture mean? Well, when I first saw this as a student, it looked like crap. It looked like gobbledygook. It didn't make any sense to me. It looks very chaotic. But let me explain to you a little bit about the physics here very quickly. As I told you, the universe started off very hot and dense in some kind of primeval plasma. I want you to think about the seething surface of the sun, boiling with energy of primordial subatomic particles that want to become hydrogen so that it can become stars, so that stars can process heavy metals, so that a star could die and make planets like our own. So this lineage, starting from this early universe, and as the universe expanded, it cooled. And when it cooled, the proton was able to trap the electron. And what we're seeing in this picture here is light that is emitted. Because remember, it takes light. Light escapes when the electron gets what we call recombined, when it forms hydrogen. So what we're looking at is the first time that the universe emitted light. But it didn't emit light at all the same colors. All these different colors correspond to the energy of the light. So I want you to think about, so what it's doing is tracking the fact that the early universe was what we call a vibrating plasma. A plasma, right, is a charged medium that carries pressure waves. What's another word for a pressure wave? It's a sound wave. So the universe is vibrating with sound waves of the primordial plasma. The universe cools to the point where hydrogen is formed, and then gravity takes over. And that hydrogen starts collapsing to form the first structure in the universe. But there's a word for this, the idea that maybe the universe began with sound started with the Vedic philosophers, and this was called Nada Brahma, Nada meaning sound, and Brahman, the ground of all being. So I found it to be very interesting that I guess the ancient philosophers beat me to this idea, okay? But so let's now understand this physics. To understand this physics, we need to understand the physics of wave. I'm sorry. What we have here are these waves. So I take waves of different vibrational undulations or frequencies, and I add them together. Notice that what happens, I create a very complicated wave. I could take a complicated wave, though, and decompose it into simpler wave patterns. This is what we call a Fourier transform. And as I just demonstrated that with my instrument, that's exactly what my instrument was doing. So let's actually go back to the instrument to try to see if we can understand something about the early universe. If I play a note on this instrument, this is a very important, please give me your attention on this one. This is a subtle point. I'm going to play the note G on my instrument. And on the vertical axis is the loudness of the instrument, but not the loudness on the x-axis going across. Every point is a given frequency, a given note, a given tone. So when my instrument plays a G, you see the point, the peak that's the highest, that's what you're hearing with your ears. But the instrument is playing a spectrum or a range of frequency all at the same time. But you're not hearing it as a G. You're hearing it as it sounds like a saxophone. If I use a flute or a piano and it played a G, it would still have that high peak there, but all those other points would change. It's called the signature, okay, or the spectrum of the instrument. What determines that? Well, the material makeup. If the instrument is made up of metal, a different type of alloy versus wood, its vibrational response will actually pick out different peaks. So also the geometry, the shape of the instrument will inform that. So that's good to know. So let's go back to our picture of the early universe. And we want to understand basically some information about this very chaotic looking data. And so what we're going to do is look at the frequencies, the different frequencies that this thing is playing, is vibrating. And when we do this, lo and behold, we see to your left something that looks like a vibrating instrument, that the universe plays a fundamental, that's the highest peak, and it has these other peaks. So we can now use the same analogy and say, well, if we can use the analogy that the different peaks in an instrument gives me information about the material makeup and the geometry, can we do the same thing? And it turns out that you can. The first peak corresponds to what we call the expansion rate of the universe at that time, the Hubble parameter. And the third and second peak on their relative sizes predict the amount of dark matter that is needed in the universe and the amount of baryonic matter that we see around us. And the amount of neutrinos and photons can all be predicted with percent accuracy. The black curve here is a theoretical prediction of the equations, and the data points here is actually the confirmation of this idea that the universe is in fact vibrating like an instrument. I now want to end my talk by saying that we don't have it all figured out, because we can ask what started this vibration. And we believe it had to do with quantum, that the early universe started off in a very quantum mechanical state. The same thing I tell about this electron and all these things improvising, that in the early universe, the universe was probably fully quantum. And this quantum universe had quantum vibrations that now led to you and I. This very weird quantum stuff. But there are gaps in between, and there's a lot that we still don't understand. And maybe that's why I still have a job. We still don't know what most of the universe is. This is a picture of a gravitational lens, the fact that space-time gets warped, and what you, instead of seeing one galaxy, you see multiple copies of the galaxy being warped. That's real data. And the fact that the universe, 70% of it is an invisible form of energy that we call dark energy, because we don't know what the heck it is. And so we don't know what these things are. It's still a big mystery. And I'm going to skip that slide. I want to kind of end that at the end of the day, after all is said and done, all the structure that's formed in the universe, the most complex structure and probably the most influence is life. And this is where we find ourselves here at this incredible workshop. And I definitely want to thank the leadership. I want to thank both deans and the leadership of UE and all the collaborating universities. It's a great honor to be here. As I said, I've always considered myself to be a son of the soil. And I kind of want to end with a few things, moving forward. And the first is that, one of the things I'm currently interested in is how quantum mechanics plays into life. And I've always been interested in biophysics. And it took me coming to Trinidad to find a collaborator in Professor Roger Andrews. We published 2 papers on this. And I also want to talk about actually the origin story, which was many years ago. I used to come here. At first, it used to come to Carnival, but I get tired of the fete. So I decided one day I was just going to drive down to Las Cuevas by myself. And I was sitting on a hill, and then an idea of watching the waves, and an idea came to me. And I started writing down equations on the sand. And I kept coming back year after year. Trinidad and Tobago, the Caribbean, started to become a place for me to actually do my thinking. That gave me the hidden advantage so that when I went back home to the States, I had a hidden advantage. And that I started to tell my friends many years ago in the States and in Europe about how the Caribbean is an ideal place for us to come and convene and do our research. It's a hidden advantage. But it also killed 2 birds with 1 stone. It was also a way for me to continue to build community with fellow Caribbean scientists and engineers. I made a friend of Professor Hack and a collaborator many years ago. And so when the opportunity came, I became friends with a billionaire named Jim Simons Foundation. Told him the story, told David Sprinkle's story. People started to buy in. They started to warm to the idea. And we secured some couple of bucks. And for 3 years running, we had this workshop that brought together on the order of 60 scientists from across the globe to come to the Caribbean. We started the first 2 years in Tobago to collaborate with our colleagues and students in the Caribbean to broaden networking and opportunities, connections, mentoring opportunities, so that we can build together, that you're not alone, and that there's a hungry diaspora who is willing to play in the sand, no pun intended, with you. And so there's a picture to the right there is my colleague, Michael Koslitz, the Nobel laureate in physics. Professor Alex Aman, who is a Trini and is now a professor at Princeton University. Jim Gates, the guy that looks like Morgan Freeman. He was President Obama's science advisor. We have the principal, who has been very undyingly supportive of this initiative, Rosemary Antoine. Everyone is there, and we're going to continue this. I just found out that we have another 3 years of funding for this to continue on, and I look forward to working with you all to build this future together. I'm very excited about, and we have sunlight in abundance with the world's best natural laboratory for light harvesting and quantum photonics, amongst many things. Tropical organisms, we're one of the biggest biospheres out there. And we are a crossroads culture. Our interdisciplinarity is our lifeblood. That's what we do best. So let's do it now as we embrace this new frontier. Thank you very much for your time.
Thank you, Prof. It was such a tour. You gave us, thanks for taking us for a mini tour of the cosmos. I actually forgot looking at my wristwatch. We assured you 45 minutes. I think you took exactly what we assured. So, ladies and gentlemen, we have a little surprise for you. Professor Stephen Alexander is not just an internationally renowned theoretical physicist and cosmologist, but he is also an accomplished jazz saxophonist. So we have a rare privilege of experiencing not only Professor Alexander as a scientist, but as a musician. So I request Professor Alexander for rendering this small musical interlude. Please join me in welcoming again musician Professor Alexander.
Shire said he's going to sing.
Yeah.
Okay.
People have to bow.
Okay. I'm going to do two renditions. One of them familiar to those of you who like the rum shop and stuff. That's always good. Oh, by the way, my grandfather's from San Fernando. All right, Sando. Now they're making soca samba Sando. Why do you do that? All right. So this first song was written by Mango Santa Maria from Cuba and adapted by him. I'm just warmed up. Yeah. Thank you.
Wow. Oh my, wow. Mesmerizing, hypnotizing. Unfortunately, we don't have much time to describe all this wonderful performance, both his talk and his music. I'm also an amateur musician, so I know enough just to appreciate when I see and hear good music. So thank you very much, Stefan. We really appreciate the time and effort you have taken to, visit us and contribute to our conference. Thank you very much. So we are coming now close to the. So we are now very close to the end, and we must acknowledge individuals and organizations who have contributed to today's event or to the conference. And I now invite Ms. Antoinette Williams from the Dean's Office, Science and Technology, to bring a vote of thanks. Antoinette?
Good morning, everyone. On behalf of the Faculty of Science and Technology, I would like to acknowledge all of our presenters. First of all, Professor Duraisamy Saravanakumar. I'm the director of the School for Graduate Studies and Research. Next, we have Professor Donnie Boodlal, Vice President, Research, Academic and Student Affairs. Professor Aldrie Henry Lee, who is the Pro-Vice-Chancellor of Graduate Studies and Research. Next, we have Professor Jaya Rawal, our Deputy Dean for Graduate Studies, Research and Innovation. And finally, Professor Stephen Solomon Alexander. Thank you very much for your contribution. We would also like to acknowledge our sponsors. I know you all are seeing them up here, but we still want to verbally acknowledge them. First, we have Analytics Technologies. Second, we have the Beacon Insurance Company Limited, Cardiac Benefits, CIC Insurance Brokers Limited, and the St. Augustine Medical Laboratory Limited. In addition to this, we would like to acknowledge our partnering institutions, the University of the West Indies Mona Campus, the University of Technology Jamaica, the University of Guyana, the University of the Southern Caribbean, and the University of Trinidad and Tobago. We would also like to acknowledge Professor Bisham Ramlal, who is the Dean Faculty of Engineering, for his unwavering support for this conference. Additionally, we would like to thank our colleagues in marketing and communications and the bursary, the staff in the Faculty of Science and Technology, and the students and volunteers who also assisted us. Finally, we want to acknowledge our organizing committee and the subcommittees. Our subcommittees are the stakeholder and technical committee. They were responsible for reviewing all the abstracts, etc. The program and logistics committee, for which we want to show a sincere appreciation to Dr. Rajamani Kam, because he went on above and beyond what he was required to do. So we want to say sincere thanks to him. Yeah, that's it. Thank you.
Thank you very much, Antoinette. And thank you very much, everyone, for being present. And thanks for all our sponsors. Thank you very much, Stefan, again. So we basically have come to the end. We have refreshments, light refreshments for everyone at the undercrop just behind us, behind this building here. And just to give some brief housekeeping, I'll ask Prof. Jaya to come.
Thanks, Chair. Session 1 and 2 will be done in lecture theater 2 and 3. So the presenters, please go and upload your files as soon as you grab your snacks. And we have to start to catch up the time. We have to start quickly. So maybe 10 or 15 minutes for this break. And the washrooms are on my left. So I will see you in lecture theater 2 and 3 for session 1 and 2. Thank you.